Hello, welcome back to LK Tuition. My name's Lucas and today we're going to be looking at speed, density and pressure. So there's three formulas that you need to learn, but they're all very similar and you can work with them all in exactly the same way. Hope you're well and let's get started. Alright then, so let's start with speed. Okay, so this equation for speed is given by speed equals distance over time. And if ever you forget these formulas, there's usually a clue in the question. So the question might give you the units for speed. So the speed might be, I don't know, meters per second, or it might be kilometers per hour, something like this. But these are actually clues that tell you what the formula is. So this is meters divided by seconds, which is distance divided by time, and this is the same, distance over time, and this over is the same as divide. So there can be a little clue for you to remember it, but the equation that we want to remember is speed is distance over time. Now what you can do is you can use the following formula triangle for questions on speed. So here's a thing that can help you remember it. So speed is distance over time, and we can use this formula if we want to find out other things as well. So instead of finding the speed, we can find the distance. And the way this works, and this is with all of these formula triangles, a lot of them are used in physics, is that this on the bottom is a times, and then if it's on the top and the bottom, then it's a divide. So what you'd do is, if I wanted to figure out speed, I'd cover up speed and I'd be left with distance over time. Let's see if I can just get rid of them. If I wanted to find time, so then that would be distance divided by speed. And then the final one, if I wanted to find out distance, then you look at the other two, and that is speed times time. Okay, so we can use this formula to work it all out. Okay, so let's just have a look at some examples. These are all without a calculator and all to do with speed. So let's just get our triangle up. So it was speed is distance over time. Okay, and now let's have a look at the questions. Feel free to pause the video or we'll just do them together. So number one says, what is the average speed of a car travelling 150 miles in 3 hours? So we want to work out the speed, and we know that speed is distance over time. Now for this, our distance is 150 miles, so 150, and our time is 3 hours. So 150 divided by 3, well, that is going to be 50. And what are the units? Well, it's miles per hour, so mph, for miles per hour. Alright, number two, what is the average speed of a helicopter flying 840 kilometers in 7 hours? So again, we want the speed, so speed is distance over time. And our distance this time is 840, and our time is 7. Now 840 divided by 7, you could use the bus stop method, or we've got 84 divided by 7 is 12, and then stick the 0 on to 120, and the units are kilometers per hour, so kilometers per hour. Alright, number three, how far does a man running at a speed of 8 meters per second for 15 seconds travel? So what's it asking for? Well, it's saying how far, so that means it wants the distance. So if I want the distance, I'm going to be looking at speed times time. So distance is speed times time. The speed is 8 and the time is 15. So we want 8 times 15, which is 120. Now, what are the units? Well, it was meters per second, and then we've times by seconds. So we're just left with meters, aren't we, for the distance? So this is 120 meters. And then finally, question 4, if a plane travels at a speed of 250 miles per hour and covers a distance, my head's in the way, a distance of 2,250 miles, how long was it travelling for? So this time we want how long, so that is time. So if we want time, that's going to be distance over speed. So time is distance over speed. Our distance is 2,250 miles and our speed is 250. Okay, well, how many 250 is going to 2,250? Well, you've got 250, 500, 750, 1,000. So 4 make 1,000. So 8 would make 2,000. And then one more to make 2,250. So this is going to be 9. And because it's miles per hour and miles, the time is going to be in hours. So it's going to be 9 hours. All right then, so that is speed. Now let's have a look at density. It's all very similar. So the equation for density is given by density is mass over volume. And again, the units might give you a bit of a clue. So the units might look something like G over centimeters cubed, so grams per centimeter cubed, or you might get kilograms per meter cubed, something like that. But again, these units for density tell you the formula. It's mass divided by volume. Okay. And again, we can use a triangle. So here we go, we've got density is mass over volume, and we're going to use it in exactly the same way. So here are a few more questions. This time you can use a calculator if you want to, what you should do. So let's just draw out the formula again. Density is mass over volume. And feel free to pause the video and have a go. Otherwise, we'll do them together. Alright then, this is the first one. It says, what is the density of a rod of aluminium that has a mass of 575.4 grams and a volume of 210 centimeters cubed? Alright then, so density is mass over volume. The mass is 575.4. The volume is 210. So I'm going to get the calculator out. 575.4 over 210, and I get 2.74. What are the units? Well, the mass was in grams and the volume was in centimeters cubed, so it's grams per centimeter cubed. Okay, next one, we want to find out the density of 2.4 meters cubed of oil with a mass of 1,995 kilograms. So get rid of that silly question mark. So the density is mass over volume again. The mass this time is 1,995. The volume is 2.4. Okay, so again, we'll just use our calculator. So we've got 1,995 divided by 2.4. And we end up with 831.25, and the units are going to be kilograms per meter cubed. Okay, all right, number 7. What is a mass of a statue with a volume of 120 centimeters cubed made from ceramic which has a density of 2 grams per centimeter cubed? Okay, so this time we want to work out the mass. So if we want to work out mass, that's going to be density times volume. So mass is density times volume. The density is 2 and the volume is 120. So that's going to give me 240, and we want the mass, so it's going to be grams. Okay, so the mass of the statue is 240 grams. It must be the smallest statue in the world, but there we go. Okay, number 8. We want to find out what is the volume of a 4 kilogram sheet of glass which has a density of 2.42 grams per centimeter cubed. Okay, so let's be a bit careful here. So because the volume, let's grab a different colour, the volume is in kilograms but the density is in grams. So the first thing we might want to do is turn this into grams. So 4 kilograms is 4,000 grams. Okay, now we want to find out the volume. So the volume is going to be mass divided by density. So mass over density. So the mass is 4,000 and the density is 2.42. We stick that in our calculator, so 4,000 divided by 2.42, and we're ending up with 1652.89, and we'll do that, leave that as 2 decimal places, and it's centimetres cubed to 2 decimal places. Alright then, so that is density. And now we're going to look at the final question, well, the final topic, which is pressure, but again it's a very similar idea. So the equation for pressure is given by pressure equals force over area. Okay, so force is always in newtons, so it might look like newtons over centimetres squared or newtons over metres squared, something like that. And again we can use another triangle, so pressure is force over area. But again, like we said with the previous two, these units can help tell you what the formula is. Yeah, so these are units for pressure, and it's force, newtons over area, centimetres or metres squared. Okay, so again, we'll pop the triangle up. So let's use a different colour. So we've got a triangle, pressure is force over area. And we can use a calculator again, so feel free to pause the video and try this, and otherwise we'll do it together. Alright, number 9. What is the pressure of a box placed on a table exerting a force of 250 newtons on an area of 20 centimetres squared? Well, we want the pressure, so pressure is force over area. The force here is 250 and the area is 20. So this is going to be 12.5 if you put it in your calculator, and it's newtons per centimetre squared, because those are the units they've given us. Newtons per centimetre squared. Number 10. What is the pressure of an object placed on the ground and exerting a force of 25,958 newtons on an area of 1.4 metres squared? Okay, so we want pressure again, so pressure is force over area. Our force this time is 25958 and the area is 1.4. So definitely need my calculator for this one. So 25958 over 1.4, and we end up with 18541.43, let's say, to 2 decimal places. And this is newtons over metres squared this time, to 2 dp. Alright. Okay, number 11. A microwave is placed on a worktop. The area of the microwave in contact with the table is 600 centimetres squared. The pressure of the microwave is 2,450 newtons per metre squared. That should be. Work out the force exerted by the microwave on the worktop. Okay, now here, because we've got metres squared, and here because we've got centimetres squared, we want to convert the centimetres squared to metres squared. Now remember in a previous video that 1 metre is 100 centimetres, but if you're doing the squared version, you need to square both numbers. So 1 squared is 1, but 100 squared is 10,000 centimetres squared. So 600 centimetres squared is the same as 0.06 metres squared. So I've just divided that by 10,000. Okay, so we want the force. So force is going to be P times A. So force is pressure times area. The pressure is 2450 and the area is 0.06. Put that in my calculator, 2450 times 0.06. We end up with 147. We want the force, so that is newtons. Alright. And then finally then, an object, number 12, an object exerts a force of 420 newtons on the floor and the pressure is 20 newtons over centimetres squared. What is the area of contact of the object? So we want area this time. So area is force divided by pressure. So area is force divided by pressure. The force is 420. The pressure is 20. So that is just going to be 21. And it is centimetres squared. Alright then, so hope that has been useful. Let's find one more question that's a bit more challenging. And here we have it, so feel free to pause the video and try it yourself, otherwise we'll crack on together. Okay, so question 13. Material A has a density of 4.5 grams per centimetre cubed. Material B has density of 14 grams per centimetre cubed. 5 kilograms of material A and 200 grams of material B form material C. Work out the density of material C. Okay, so we're living in the world of density, so let's just do that triangle to start with. So density is mass over volume. Again, if you forget that, then it's here. It's mass over volume, like that. So to work out the density of material C, what do we need? So the density of material C is going to be what? Well, it's going to be the mass of C divided by the volume of C. Well, we can figure out the first one already because the mass is going to be these two weights added up, because we've got that 5 kilograms of A and 200 grams of B come together. So we can definitely work out the mass. So let's do it in grams, because this is in grams. So we'll keep this 200 grams, but we'll make this 5 kilograms the same as 5,000 grams. So the mass of C is going to be 5,000 plus 200, which is 5,200. So we'll keep an eye on that. So 5,200 grams. Now we want to work out the volume. Now we don't have the volume of either of them, but if we know their mass and if we know their density, we can work out the volume. So let's start off with A. So the volume of A. Now let's use our formula. So the volume is going to be mass divided by density. So the mass of A divided by the density of A. Now the mass of A is 5,000 and the density of A is 4.5. Oops, just draw a slightly better 5. There we go. So let's just do that in our calculator. So 5,000 divided by 4.5, and we end up with 1,111.1 recurring. So we'll leave that as it is for now. So that's centimeters cubed. And then the volume of B. So let's grab a different color again. The volume of B is again the mass of B divided by the density of B. Now the mass of B is 200 and the density is 14. So again in my calculator, 200 divided by 14, that gives me 14.2857114 with dots on them. Okay. So the volume then of C is going to be these two added up. So let me just grab another colour, running out of colours to try. So the volume of C is going to be these two added up. So it's volume A plus volume B. And I'll just do that straight in the calculator. So plus 1111 point, like that. Great, and then let's do it to 2 decimal places. It's going to be 1125.4, let's say, because it rounds up to 40. So that is centimeters cubed. That was centimeters cubed as well, to 1 decimal place. Okay, so now we've got the volume. Don't forget that extra one that I've just scrubbed out. And we've also got the mass. So finally, we can do the density. So the density of C it's just going to be mass over volume. So let's just write that, mass of C over volume of C. The mass is 5,200 and the volume is 1125.4. Great, stick that in my calculator. So 5,200 over 1125.4, and we end up with 4.62 grams per centimetre cubed, and that's to 1 decimal place. Alright then, so quite a challenge one to finish off with, but if you followed it then you've done really well. Okay, so I hope you found that useful. Please don't forget to like and subscribe, and I'll see you soon for some more maths videos.